We're going to start this screencast by creating a small text file with a single line of text in it, and we're going to save it to location that we'll be able to find again. I'm using the file folder in my C drive, and we're going to call this file small.txt. Then we'll go ahead and create a new project, and we're going to use the command line app template, and we're going to call this checked exception example. So what we're going to start out doing is we're going to create a new class, and we're going to call it FileReader. And we're going to provide FileReader with a single method called read file. And we're going to have it take a single argument, a string that describes path to a file. We're going to create a new file object, and we're going to initialize it with the path specified in the method call. And of course we need to remember to import the file class. And now we're going to create a new scanner, and we're going to pass the file object to a new scanner object, like so. And of course we need to surround this scanner, as we previously learned, with a try-catch statement. And that is because the scanner constructor throws a checked exception, namely the file not found exception, in case the file specified on the path does not exist. So we already know that. The thing is that there may be other things that are currently not captured by our code, right? So maybe we in our program require a specific format of the text file that we're reading. And maybe that specific format is that it should contain exactly 2 lines of text. So we will try and print exactly two lines of text from our scanner by having it read the next line in the file. Now what's going to happen when we do this is that actually we do not have 2 lines of text. So if we go ahead and try and run this code, so in here in the main we're going to create a new FileReader object. FileReader is the class that we just created. And we want to read from the file that we created before, so we will specify the path here. Remember to escape the backslashes. So if we go ahead and run this code, we'll see that an exception that we are not aware of is thrown. This is the no such element exception, and that is because we're trying to read a line of text that does not exist. Now, once we are aware that such a condition exists, we can do something about it. So the reason that this is thrown as an exception that we haven't caught is because we are not explicitly catching it down here. It does require us to do so, because no such element exception is an unchecked exception. But that doesn't mean that we can't do it if we need to do it. So under certain circumstances, it might be useful for us to catch unchecked exceptions as well, and we're completely allowed to do so. So we're going to specify here that we want to catch the no such element exception. And what we're also going to do is, well, to begin with, we'll just validate that we are able to do this. So we'll do it like this, and we will go ahead and write out the text. File format is wrong. Or actually, file contents are wrong. So now, hopefully, our program should run without a problem, aside from the fact that we'll have a printout here saying file contents are wrong. Now what we're going to do is actually, we don't want to print out this text. We want to throw an exception that makes the call of this method aware that actually the file path that you specified led to a file that did not adhere to the requirements that we have for an input file. And the way that we're going to do this is we're going to create a new Java class. And this Java class we're going to call, what could we call it? We could call it invalid content exception. Now, the class invalid content exception, we're going to extend the exception class from. Now, when we do this, what we are creating here is our own custom checked exception. It will be checked and checked exception. If we extend the exception class, we could make it unchecked as well by extending the runtime exception class, but we rarely do so. So in here, we're going to provide it with a constructor. And this constructor will call a constructor in our superclass, which is the exception class, that takes a string as an argument. File contents does not adhere to requirement. Now, arguably this is not the best description, but nonetheless it serves the purpose of demonstrating how to make a custom exception. So once we've created our exception class, we can go ahead over here, and if the no such element exception occurred, we know that the file contents were not adhering to the requirements that we had. So what we can do is we could say, actually, we're not going to print out anything. We're going to say throw new invalid content exception. Now, this will give us a red line here, and that's because we did not say that this method actually threw exceptions. In order to signal to the outside world that this method could throw an exception under certain circumstances, what we are going to do is add the throws keyword and then invalid content exception up here. We see that now we are allowed to throw an exception from this method, but we should be aware that anywhere where this method is now called, we should handle the fact that it throws a checked exception. So if we go into our main here, we'll see that now we have a red line under our method called to read file method. And the way that we'll handle this is we'll surround this with a try catch block. And then out here we can print out to the user, sorry, the file on the specified path does not comply with requirements. Again, arguably not the best description. And we could also print out the contents of our exception object. So we could say system out print ln, and then in here we could say e.getMessage, and we could also print a stack trace. Like so. So let's go ahead and try and run this and see if our custom exception works as we anticipate. Sorry, the file the specified path does not comply with requirements. File contents does not adhere to requirement. And then we can see that actually we cannot print stack trace this way. Actually, what we should have done was to say e.print stack trace like so. Then we can try and execute it again and see that here we see the stack trace. And of course, this is mainly relevant to programmers, but nonetheless, we have the option to do so. And so this is how we create our own custom exception. We also see this is how we throw a custom exception. We have learned how to use the throws keyword, and we have seen that the consequence is that now everywhere where we call the method that now throws an exception, we need to surround it with a try catch statement. Alternatively, of course, we could add another throws up here to propagate the exception all the way up to the virtual machine, but that would just lead our program to crash instead, and we don't want that in this example. So this is it for now.